Swayam Prabha. Digital India. Educated India.
In this lecture, we are going to look at production technology and its interface with society. In today's context, there are several sectors of production. One, agriculture is the primary sector, industry is secondary, and of course, there is a lot of production of services in the tertiary sector. First, we'll focus on industrial sector and see how technologies have been changing the process of production and how the industries have been adapting, or how the workers have been trying to protest against new technologies and then ultimately getting used to the new technology. So, in the last lecture, I talked about Karl Marx's Sociology of Science, and where he looked at science and its role in the capitalist society. To recall, science plays a role in changing sensuous consciousness. That means our ideas of nature, our ideas of surroundings. And also science plays a role in trying to make us understand the material world and also to change the material world. Science has become a direct force of production according to Karl Marx, and it enters production industry and also production agriculture. He mostly focused on industry. Science is integral to the process of labor alienation. We have said in the capitalist society, because of the invention of machinery, introduction of machinery, the machinery challenges the worker as his competitor, and machinery is basically objectified labor. That is, one's own product poses challenges to oneself. Then he said machines are products of human labor or objectified human labor, and act as competitors' workers. And the tendency in capitalist societies is to invest more and more in machinery and equipment, so that they can minimize the involvement of labor, minimize the cost of labor, and also to see that they do not have interruptions in the work. Sometimes, as I said in the last class, the machinery is introduced or any improved technique is introduced with the idea of productivity and efficiency. But sometimes new machines are introduced, new equipment is introduced, not to achieve efficiency or productivity, but to control labor, but to see that labor is minimized and also they can control labor. We will see how this happens in the society. Marx also said, to recall, ruling ideas of an epoch or the ideas of the ruling class. By controlling the material resources in the production process, the ruling class also controls the mental production. That means ideas. That is, in a capitalist society, the kind of knowledge that is generated is generally associated with the production process, associated with how to increase the productivity of capital. Let me give an example. In our textile industry, when it was introduced in the 1850s, one worker was operating 2 looms, and then it became 4. One worker was operating 4 looms, then he started operating 8, then he started operating 16, and today a worker operates 32 looms. That means a lot of mechanization, automation has taken place. That means labor has been displaced, and that's how the investment in fixed capital, that is equipment and machinery, is generally made by the capitalists so that they can minimize involvement of labor. And Harry Breverman, another influential writer on technology and society interface, basically is a Marxist in orientation. Breverman observes that over time human control over tools and their action increased. The action of tools is guided by electrical chemical and other physical forces. The tools are controlled in their activities as extensions of human organs, including sensory organs. This feat is accomplished by an increasing human understanding of the properties of matter. In other words, by the growth of scientific command of physical principles. What Braverman is saying is, over time, human control over tools have increased, and basically this is based on understanding of the properties of matter, how to shape tools by using materials, and how to shape them so that they are under the control of human agents. That is, the equipment or the tools become extensions of human organs. That is, the tools which act as extensions of human organs improve the efficiency of human beings and improve the productivity of human beings. That is, it's all done, as I said, on the basis of the improved understanding of the properties of matter and to see how to make tools out of the matter or materials. The study and understanding of nature, he argues, paves the way for increasing control by humans over labor processes by means of machines and machine systems. Why do we improve? Why do we make tools? Why do we use material resources to make tools? It is basically to control the labor process. It is basically control how we produce. It is basically to control the production process. Braverman argues that at a concrete level, the control of humans over the labor process turns into opposite and becomes control over the mass of humans. What basically he is saying is, by introducing tools in the production process, which are supposed to aid the workers, they become exactly opposite and they start helping the capitalists to exercise control over labor. Let me quote, "Machinery comes into the world not as servant of humanity, but as the instrument of those whom accumulation of capital gives the ownership of machines." Basically, the machines help those who own the means of production. Basically, machines are introduced by those who own the means of production, that is, the capitalists in the contemporary world. They introduce machines to improve productivity. If you look at the history of capitalist development and technology development, over time we have been moving from labor-intensive technologies to more and more labor-saving technologies. This has happened across the world. In India also it has happened and it's happening. So the logic of technology development in a capitalist context is to improve productivity of machines rather than the workers, to improve productivity of machines so that labor involvement can be minimized. Again, Harry Braverman says, the capacity of humans to control the labor process through machinery is seized upon by the management from the beginning of capitalism as the prime means whereby production may be controlled, not by direct producer, but by owners and representatives of capital. What he's saying is, the introduction of machinery does not help the direct producer, that is the worker, but it helps people who own the means of production, manage the means of production. As I said in the last lecture, that in today's context, owners do not directly manage production. There is separation of ownership of means of production and management of means of production or control over production. That is, there is a professional managerial class which tries to manage production. And as I said, today's companies, big companies or joint stock companies, the ownership is distributed across the society. And in actual production, it is the professional managers who are involved. And these professional managers' interests are closely related to or tied to the interests of those who own the stocks. And some companies also give stock options for the managers, and they also get some preferential stocks at preferential rates. Then again, Braverman says, along with these conditions, a social evolution must take place which parallels the physical evolution of machinery. That is, along with machinery, when machinery evolves, the social organization of production also evolves and changes. step-by-step creation of labor force in place of self-directed labor, human labor, that is to say, working population conforming to the needs of the social organization of labor, in which knowledge of the mission becomes a specialized and segregated trait. While among the mass of working population, there grows only ignorance, incapacity, and thus a fitness for mission servitude. Basically, as the machinery, more and more machinery are introduced, workers are expected to know about the machinery, and they also should adapt themselves to the requirements of the machinery. That's where he says it is servitude toward the machinery. That means they are subordinated to the requirements of machinery. And those mass of workers, there grows only ignorance, incapacity, and thus a fitness for mission servitude. That means they are made to be subservient to the machinery, and they will not be able to use their mental capabilities in the production process, because it is a mission which dictates what they should be doing while they are engaged in production. For example, if you look at the conveyor belt or an industry based on which uses conveyor belts, you will see the workers typically do certain operations at different stages of the conveyor belt. This happens actually in automobile industry. A worker is supposed to perform a particular task in 2 seconds, 3 seconds once the particular motor car arrives at a station. He is not given more time, and if he doesn't do within 5 seconds or whatever, 10 seconds, then there is always a backlog of vehicles standing, and he is under pressure to do it fast. That means the worker does not have a freedom to exercise his mind while he is participating in production. They become cogs in the wheel, and they are supposed to perform specific tasks within a time frame, within a time limit. So this is very, very clear if one looks at the production of automobiles everywhere in today's context. They are based on this kind of division of labor, where every worker performs a certain particular task at a given point in time when the vehicle comes and stands on the conveyor belt where he is stationed. So this is how he becomes a kind of a servant to the mission, right? So Braverman again says, in this way, the remarkable development of machinery becomes, for most of the working population, the source not of freedom but of enslavement, not of mastery but of helplessness, and not of the broadening of horizon of labor but of the confinement of the worker within the blind round of the servile duties in which the machine appears as the embodiment of science and the worker as little or nothing. In the sense, the remarkable development of machinery, which also requires a lot of knowledge to make this machinery. As I said, technology always has, it's not merely an artifact. There is a law, there is a kind of knowledge that is involved in construction of this artifact. The knowledge could be drawn from early technologies, knowledge could be drawn from science, and the missionaries does not really liberate workers but enslave them. They add to the mastery of the workers, but it adds to the helplessness of the workers, or creates helplessness among the workers, and not of the broadening of the horizon of labor but of the confinement of worker within a blind round. Means that his mental horizon will not increase. He will become more and more confined to the narrowly defined duties. And the mission appears as the embodiment of science, as embodiment of knowledge, embodiment of creation of scientists and engineers, and the worker is almost reduced to little or nothing. Increasing control over labor process through machinery leads to de-skilling of workers. When machines are not there in the early development of capitalism, the worker could deploy his skills in the work process. That possibility is taken away by the machinery. Basically, what over time, earlier if you look at earlier stage of capitalist development, the worker still had skills, they could use their skills in the production process. That means they were able to use their mental capacities, capabilities in the production process and actively participate in the production process because they are mentally also, both physically and mentally engaged in production. But that possibility is taken away by machinery. Over time, the worker is reduced to merely a cog in the entire production wheel, and the machine takes away all his capabilities. And for example, in the phase of mechanization, what you see is the production process. The production process is governed by energy that is drawn from inanimate sources. The worker is supposed to perform certain tasks, and as the technology develops, the worker's role becomes narrower and narrower rather than a broad role. So that's what with mechanization. In the case of automation, as we're going to see in the next few minutes, automation is another phase in the technology development where the machines become intelligent and they take certain decisions which are based on the kind of instructions given to the machines by computers, centralized computing facilities. See, you can also see some cases where there are instances in history of technology where the workers resisted the intense pressure of work, or when the skilled workers in the factories, especially in industries such as cotton mills, went on strike, then the production was affected. To get over this problem, concerted efforts are made to introduce innovations which reduce the dependence on skilled workers. This happens all the time. I said it's a general kind of a tendency, a trend to reduce the involvement of labor by producing machinery, and especially because the workers resist, the workers protest, the workers demand more wages, the workers demand better working conditions. It's all because of this, because workers are creative agents, they are creative subjects. They not only react to the situations, but they also can create new situations. That is why whenever they feel that their wages are not enough, whenever they feel their working conditions are not good, they try to protest. It is basically to avoid this kind of protest, enterprises or entrepreneurs resort to investment in machinery, or think of innovations, think of producing things by using new machines. Let me give an example. In the 19th century, master spinners in the cotton mills in the late 19th century in Britain were highly skilled and they had a central role. If they struck work, the whole production would come to a standstill. It is in this context that manufacturers came together and resolved to reduce the dependence on the master spinners. This led to invention of a self-acting or automatic spinning mule. In the sense, the labor is at least partly eliminated by introducing this invention, that is a self-acting or automatic spinning machine, spinning mule, and this has really reduced the involvement of workers and of course saved, and it really helped the capitalists to save on labor, save on the or increase production. David Noble did a study on the social choice in machine design. He basically worked on how numerically controlled machines came into existence in a machine tool industry. This is a case study which deals with the labor process shifting from involvement of manual labor to numerically controlled machines that followed commands given by numerical codes through semi-automatic recorded tapes that were used by workers in the production of various kinds of products, ranging from products with certain shapes, sizes, sometimes very important precision products. In the sense, it moved from manual to semi-automatic and then numerically controlled stage. That means it is controlled by the machine tool behavior is controlled by today computers, numerically controlled machines. Nobel observes the advent of the new technology, numerically controlled machine tools, has produced something of a revolution in manufacturing, a revolution which, among other things, is leading to increased concentration in the metalworking industry and to a of the production process in the direction of greater managerial control, in the sense that the decision-making process is becoming more and more centralized, because it's now possible to give instructions to the machine tools, and these instructions are stored in computer, and there are numerical codes which guide the machine tools. Machine tools are very extremely important. Machine tool making or machine tool industry is important part of our capital goods industry, and machine tools produce, as I said, products with different shapes, sizes, sometimes precision products which are required in various industries. It means machine tool industry is not a mass production industry. It produces custom made products for different industries, and it is customized production which makes this industry not a mass producing industry, and that's why it is sometimes people think it's expensive to invest in improving technology in this kind of industry, because the kind of margins they have, the kind of volume of production they can think of are not very, very high, because they produce different kinds of things for different industries, and these requirements are maybe not very, very large. So that's why this machine tool industry is a different kind of industry compared to a mass producing industry like a textile mill, or which produces a lot of cloth. It's not a mass production industry. Right? Nobel observes that the advent of has produced something of a revolution in manufacturing, which has led to more and more centralization of decision making. This technology was developed by large-scale metalworking firms, and Nobel asked these questions. Nobel asked the following questions. Why did this new technology take the form that it did? A form which seems to have rendered it accessible only to some firms, and why only this technology? Is there any other way to automate machine tools, or a technology, for example, which would lend itself less to managerial control? To answer these questions, he examines the dynamics involved in the development of new technology. As I said, to look at these stages, the machine tool industry moved from manually operated machine tools to cut, to shape, and to size materials for various purposes, and this required skilled machinists. A skilled machinist is the one who understands the movement of the tool, understands the requirements of the customers, and accordingly uses his mental capabilities to achieve the goal, to produce the product which the customer requires. This is where I said the workers in earlier stages use their mental capabilities to produce goods. Next, we move on to the stage where semi-automated machine tools, that, for example, there is an example, the kind of technology that was used was tracer technology, which was based on hydraulic or electronic sensing devices that conveyed information to a machine tool as to what it should do. That is, a machine tool is something which is going to perform certain tasks in shaping a particular product, in cutting a particular material according to the requirements, and in sizing particular material according to the requirements. Now that means, earlier, as I said, the skilled machinist was able to do this, perform these activities, and as again skilled machinists were indispensable for this, and as a way of trying to reduce involvement of skilled machinists, the move to this, the next stage was the semi-automated machine tools. And the final stage today that we have is numerically controlled machines, cutting tools were given instructions in numerical codes. So this is, now these codes are, this information regarding instructions is stored in a computer. It is a computer which actually guides the movement of machine tools. A machine tool, for instance, the lathe or a milling machine, I'm sure many of you have seen lathe machines. If you go to a small town, you will find lathe machines, a machinist again, who is trying to, for example, cut threads around a pipe. He is trying to cut some pipes to a particular size, and so on. Right? If you go to small towns, you will see these lathe machines. A machine tool is a machine used to cut away surplus material from a piece of metal in order to produce a part with the desired shape, size, and finish. Machine tools are really the guts of machine-based industry because they are the means whereby all machinery, including the machine tools themselves, are made. The machine tool has traditionally been operated by a machinist, as I said, mentioned just now, who transmits his skill and purpose to the machine by means of cranks, levers, and handles. You will use several kind of instruments while shaping the tool, shaping the product. There are cranks, there are handles, there are levers, and he gets the feedback through his hands, through ears and eyes. He is observing while he is doing this shaping. He will get some feedback. He is observing. He is listening to certain sounds when he is producing this, and this is what provides us feedback to him. His sense organs provide feedback to him. These mechanical devices relieved the machinist of certain manual tasks, but he retained control over the operation of the machine. These mechanical devices like cranks, levers, and so on took away or gave some relief to the machinist from drudgery, but his core skills, core competence remained in trying to shape the products. See, automating a machine tool is different from automating, say, automotive manufacturing equipment, which is single purpose, fixed automation, cost effective only if high demand makes possible a high product volume. See, as I said, machine tool industry, machine tools are general purpose, versatile machines used primarily for small batch, low volume production of parts. The challenge of automating machine tools then was to render them self-acting while retaining the versatility. As I said, the machine tool industry is not mass production industry. As I just now read, machine tools are general purpose, versatile machines used primarily for small batch, low volume production of parts. That is, the requirement of a particular part in an industry will not be much, right? So obviously, because of the low volume production, and different kinds of things that the machine tool industry produces, is a versatile industry. Obviously, automating this is a challenge. If it is one particular product that's being made by machine tool industry, it is rather easier to automate it. But if it's producing several products in small batches, it's a problem, a challenge to automate it. You must have what is called flexible automation. The automating of machine tools then involves two separate processes, according to Nobel. The tape reading and machine controls. That is, machine control is a means of transmitting information from the medium to the machine to make the tables and cutting tool move as desired. That is, you must guide the machine tool to shape the product. That is information that is required. The machine tool must have that information, what it should do. How do you provide this information? Right? There should be, as a means of getting the information or the medium, that is the tape, in the first place. The real challenge was how to put the information on the tape. The first viable solution was record playback, a system that developed in 1946-47, General Electric company and a few smaller firms. It involved having a machinist make a part while the motions of the machine under his command were recorded on a magnetic tape. After the first piece was made, identical parts could be made automatically by playing back the tape and reproducing the machine motions. That is, to start with, a machinist was involved in commanding the machine tool to perform certain activities so that a particular product of a particular size, particular shape is produced. Once that his commands are recorded on a tape, this tape could be replayed, right? And then the machine could follow the instructions and then produce exactly the same kind of products that were produced when the machinist was in command. In 1952, the first numerically controlled machine tool, a vertical milling machine, was demonstrated and widely publicized. This involved collaboration between John Parsons, a subcontractor of the US Air Force, and the engineers at the MIT, Massachusetts Institute of Technology, US. In the process of innovating the numerically controlled machine tools, US Air Force played an important role. US Air Force as an institution, as we know that US has a very, very strong Air Force because US has a big role as international leader, and we know that during Cold War regime, US had an enormous role to play, and that's why the Air Force has become a very, very huge organization in the US. The US Air Force invested funds to procure and transfer the numerically controlled machine tool technology to its contractors, subcontractors, and aircraft manufacturers. The cost was not a concern for these contractors, as the Air Force bore the cost or picked up the cost of the machines. The contracting firms, hence, were competing to produce according to the specifications of the aircraft industry. In the sense, if you look at how aircraft or the military procures its requirements in the US, it's all on the basis of contractors. The contracts are absolutely well qualified engineers who have their own firms, who try to do work for the Air Force on a contract basis, and sometimes if they cannot do their work, cannot do a particular task all by themselves, they approach universities for carrying out research, and this research is based on some kind of memorandum of understanding or agreement where both parties come to collaborate. And that's how in the United States we see a lot of research is supported by industry. A lot of university research is supported by industry through these collaborative projects, and that's how there is a vibrant research culture in the United States, because the industry is involved in approaching universities for consultancy and also to produce new kind of research which is useful for them. So that's how the research culture in the US has developed, because industry has a large involvement in supporting university research in the US. Similarly, federally funded projects are also given to universities, which helps the universities to continue to do research and produce excellent results. And recently, I mentioned in my earlier lecture, in 1980, the government of US introduced what is called Bedroll Act. According to this act, any university research funded by the federal government can be licensed to the industry entrepreneurs who would like to manufacture this or commercialize the production of the kind of invention that has come out from the university research. So there is a dynamism, there is university academia interaction in the US, there is university federal government interaction in the US, large funding from industry, from federal sources go to the universities for research. So whereas in countries like India, most of the research is done, that is done in the universities, is supported by government funding bodies. We do not have much of interaction with industry. Universities are not involved in collaborating with the industry, nor is the industry interested in approaching universities, because they have their own explanation as to why they don't go to universities, because of bureaucracy, because of delays and so on. There's another reason why our industry does not want to approach our universities and IITs and other academia. It is because today, over time, the government of India has been liberalizing restrictions on imports of technology. And if that is the scenario, if importing a technology is easier than trying to sort of produce it here or trying to develop alternative technologies, the industry would prefer to procure technology which is already available, to save perhaps time and also to quickly get into production, rather than approaching the universities for developing alternative technologies or developing other ways of doing it. So that is the scenario. And as I said, going back to our case study here, so because of the Air Force was involved, it helped the contractors to procure the numerically controlled missions, and the cost of these missions was borne by the Air Force. So the contractors did not have to invest in procuring these missions, so they only concentrated on delivering the products to the US. And in the process, they also collaborated with the universities. Whenever there was an issue issue in production, they would approach the universities. So it resulted in agitation of the mission operators in the industry, and due to introduction of NC mission tools, and partly de-skilling of the mission operators occurred. As I said, every new technology that is introduced will have consequences for the workers, will have consequences for the organization of work, and every time a new technology is introduced, the workers get displaced. The workers, or either they get displaced or the workload increases. In the sense, they are asked to do new tasks, they are asked to perform new kind of roles. Yeah, I just now mentioned that the introduction of NC mission, numerically controlled missions, resulted in the mission operators getting into an agitation, because they thought their work will be taken away, they will be rendered jobless, and also due to introduction of these NC mission tools, there was a de-skilling of workers that took place, at least partly. That is, their skills, like as I said initially, the machinist was a centerpiece in the mission tool industry, because he used his mental capabilities, his knowledge of materials to shape a particular product using the mission tools. But now, because of the numerically controlled missions, automated mission tools, the operators do not have to use all their mental capabilities in production, and that's how it leads to de-skilling of mission operators. In the sense that a machinist of an earlier era is no longer required to guide the mission tools to produce a particular product. Now, this happens in all industries. In India also, whenever there is new missions are introduced, the workers are displaced and they lose their jobs. And there's always a demand to retrain the workers, to build their skills so that they can be deployed in other kinds of activities. But the inexorable logic of capitalist development over the years, or inexorable logic of technological development in association with the development of capitalism, is that over time we have more and more capital intensive equipment, capital intensive processes, rather than labor intensive processes, where the labor's role is getting undermined, and more workers are displaced by automated industries. And today we see automation also in our country. We see that most of the office automation, about which we're going to discuss in a few minutes, most of the office automation also had impact on the work culture in the country. And when I was teaching at the University of Hyderabad, when first time computers were introduced, when all the secretaries or typists, the office staff learned how to use computers, then asked him, what is the difference between manual typewriting and using computer to type your text? One of them said, sir, I can produce 6 times the kind of work that I was doing when I was using a manual typewriter. That means computers help me to increase my productivity by 6 times compared to what I was doing with manual typewriters. So this is what happens as if you introduce new technology, productivity goes up, and obviously if the productivity goes up, there is less role for less requirement for workers. I gave the example of textile mills. Today, as I said, a worker handles as many as 36 automated looms, and when it started, one worker was only looking after 2 looms. So that is a kind of a trend that we see today in the process of industrial production area, and this automation is very much part of our life. We have automated services in our country, like India. For example, take the railway reservations. 15-20 years ago, everybody had to go to railway station to book his ticket or reserve his ticket. But today you don't have to do that. You can do it sitting at home, or you can approach a travel agent who can book your ticket online. You can book your air tickets online. You can do a lot of things with online operations by using computers. And this in fact had, in certain ways, it has really benefited society, because people don't have to make a queue at the railway station for booking a ticket, or they don't have to go to airlines office to book a ticket today. So this has really reduced the transaction costs that people were incurring earlier, and in a sense it is beneficial to the seekers of service. Of course, for the organization, what does it mean? That means for railways, for example, what does it mean to automate? Obviously, there are some consequences in terms of the kind of workload that a person has to take, and the kind of attention that one has to pay to the work that one is doing. So automation is there, and of course one of the important instrument that we use is a mobile phone. A mobile phone has a lot of information stored in it. A mobile phone will enable you to do a lot of operations. Like as I said, you can book your ticket, you can order food, you can do a lot of things by using mobile phone. In that sense, this instrument reduces transaction costs. You don't have to go physically to a place to buy something. It's called online buying. We have huge online shops like Amazon, you have Flipkart and so on. So I think automation has really affected every sector of our life, including manufacturing sector and service sector. And of course, today in education also we have a lot of equipment which is digital equipment, which helps in the education sector to store a lot of education material and also deliver lectures. Like, for example, what we're doing is recording lectures for making them available to wider audience through television or other ways of. Next, I'm going to discuss about what did word processing did when it was first introduced, right, as a new technology. This is a study done by Jane Barker and Hazel Downing in 1985. I mean, it appeared in a particular volume and published in 1985. And this case study shows how introduction of office automation in Europe and US and later on other countries by deploying word processors deployment of word processor changes the patriarchal culture that prevailed when manually operated typewriters were in use by the offices, and mostly these the typists were women. Women were secretaries who were involved in typing documents, in trying to type letters, that the managers, typically men, required to discharge their functions. Basically, women secretaries performed the role of typists, typically working under the supervision of male managers, as I just now mentioned. In that environment, the male managers were the bosses who allotted work to the secretaries, and the work included typing of letters, typing office documents, and other correspondence. These women also were trained in drafting documents in shorthand. I'm sure we all, when we were young, a lot of typists had to know shorthand as to take dictation from the bosses, and that convert again the shorthand into text on the typewriter. But today nobody, I don't know how many people know shorthand today. So basically what it means is all the secretaries invariably were women, and their job was to do typing. They were typists. So the kind of work that they did was, as I said, one is formal work related to their job, producing documents, typing letters, and so on. Sometimes the boss gave work which is feminine. For example, arranging get-together meetings, parties in the office. These kind of roles were seen as feminine roles, and this kind of work was entrusted to women secretaries and typists who were in charge of organizing these meetings. So we have a word like housewife. Similarly, people used to have a word like office wife. That means she, in addition to her formal work, used to perform these feminine tasks like arranging get-togethers, maybe giving or making coffee, tea for the boss, and so on. Because of this patriarchal control over women, women showed resistance in various ways. They used to delay work on some excuse, and using that time to have informal meetings with other women secretaries, and make use of the time to discuss the marriage prospects. Basically, most of these secretaries were unmarried, and they used to resort to knitting and so on. So it is one way of showing resistance against this kind of a culture, and because they were operating manual typewriters, it was easy for them to get away from the seats on some excuse or the other, and they could spend time for themselves, and that is one way of showing resistance in their daily life at the office. So this was basically, even managers, male managers recognize this, that women are trying to resort to these kind of steps to to avoid work and so on. And they obviously knew what the women are up to. They also they were trying to tell women not to resort to these things. But however, women were trying to do this. But when we move to word processing, introduction of word processors, by 1970s in Britain and US and so on, the introduction of word processor ushered in changes in the job content and the designation of the worker. With the word processors, the tasks of typists got fragmented. She no longer had to press keys to print information on a piece of paper. She had to key in the information so that it gets stored in the memory of the word processor, the computer. The printing is done separately. That is, what we do today typically is we keep on typing, typing on the computer. We don't have to type on the manual typewriter today. That means you don't have to repeat typing on a piece of paper as we used to do earlier. The word processor enabled making corrections to the text of the document right at the time of composing it. Computer, and in contrast to the time when she used manual typewriter. Several drafts could be made before finalizing the document. The standard sentences, paragraphs are stored on the machine. Setting margins and changing size of the letters were all possible. Today, the computers become so versatile in word processing, text processing, that one can do several things while composing the document, right? When you write a research paper, or when you write a letter, or when you write a document, it's possible to make changes right at the time of composing it. So, in the sense that, as I gave the example, that in our country, one of the typists now at the university said, it increased the productivity by almost 6 times. So that is a big achievement, and at the same time, it will also mean more intense work for the typists. So what does it mean? By automating, as I said, the tendency in the capitalist societies is to gain control over the labor process, to gain so that they can exercise control over the workers, over the labor. That's what we mean by gaining control over labor process. This happened in industry, and this also happened in offices, which are basically trying to perform certain bureaucratic functions. The information, as I said, the information could be copied on floppy disks and can be used as backup in case of word processor develops some problem. As I said, this office automation also helped in gaining control over the labor process in the offices, which are very different from the kind of labor process that one observes in industry. Nevertheless, there is a labor process operating in offices as well. The authors conclude that typing and training in shorthand writing, shorthand drafting, is a skill, and the introduction of word processor have undermined this skill. Though the word processor eliminates some drudgery, such as retyping, it also intensifies work, and women secretaries cannot leave the desk for retrieval of old files as they used to do earlier in the era of manual typing. Files, as all the files are stored in the memory, in the sense that today, first we should recognize typing is a skill, and as I said, some people are trained in drafting documents in shorthand, and that shorthand was converted into text on the typewriter, manual typewriter. But today, that skill has disappeared, and in that sense, the word processors have undermined the skill typing on a manual machine and drafting documents in shorthand. Of course, the word processor eliminated some drudgery like repeated typing on a manual typewriter and so on, but at the same time, it has made the work of secretaries more intensive. They cannot leave their desk for any other other kinds of activities related to work. They can't have excuses to leave their desk, and that means they are made to sit. They are made to really work throughout the day, maybe with little kinds of intermissions, which are officially allowed. They could not have same kind of informal networks, informal meetings as they used to have in the early era of manual typewriters. So basically, what the authors says, the authors conclude that a form of control which embodied social relations of men's dominance and women's subordination was replaced by a technology which isn't neutral but embodies social relations of capital's dominance over labor. As I said, even office automation is part of gaining control over labor process in the capitalist societies, and this technology is not a neutral technology. no technology is, for that matter, is neutral. So a technology operates in a particular context. A technology operates, basically the goal of technology is to improve productivity, improve so-called efficiency, and we should see who are the ones who, the gainers of the, who are the ones who gain out of this productivity, who are the ones who gain out of efficiency. This is a question that we should be concerned with. And as I said, those who gain by the efficiency and productivity are those who own the means of production, right? So all technological changes, I said, inexorably have been moving towards more and more capital-intensive technologies and trying to displace workers. And which Marx said a long time ago, that this trend has alienated labor, alienated workers in the modern context. Thank you very much.